Hello everyone. In this video, we will be discussing two important concepts on spur gears. So the first one is interference in involute gears. So we shall directly move to the discussion. This sketch shows a pinion with center open. You can able to see this is a pinion and this is the gear. So you can able to see the first. Let me discuss the pinion details. So this is the pitch circle and this is the pinion, and this is the base circle for the pinion. This is the base circle for the pinion, and this is the maximum addendum circle. This is the actual addendum circle, and this is the pitch circle. This is the pitch circle for the pinion. This is the actual addendum circle for the pinion, and this is the maximum addendum circle for the pinion. Similarly, on the other side, we have a gear, and even if you see that this is the maximum addendum cycle for the gear, and this is the actual addendum cycle, and this is the this pitch circle, and this is the base circle. I think you're very clear with these things, and we are very clear about all these things. What is R, what is PL, everything. I'll explain one thing once again in this video. So sketch shows a pinion with center oven. It is in meshing with the a gear with the center O2. So it is a pinion, the center point is O1, and the gear, the center point is O2. Now capital Mn is a common tangent. We can able to see this. This is the Mn line. So this is the common tangent line to the base circles. So we have both pinion and gear. So this capital Mn is the common tangent circle, and KL is the path of contact. Here you can able to see this. The path of contact of in between Mn is it is the KL. It is the path of contact line where the two gears is being exactly mated with each other. Now, a little consideration will show that if the radius of the addendum circle of the pinion is increased to O1n, so you can able to see this. So this KL is there, no? From this, if I extend this in this Mn, the tangent line means you can able to see this. This is the O1n line. The point of contact L will move from L to N, from move to L to N. When this radius is further increased, I am talking about this radius. When this radius is further increased, the point of contact L will be on the inside of the base circle of wheel and not on the involute profile of tooth on the wheel. It will be on the base circle. You can able to see this. So L to N means it is slightly increased. So the base circle inside it has been seen. Now the tip of tooth of the pinion will then undercut the tooth on the wheel at the root and remove part of the involute profile of teeth on the wheel. This effect is known as interference and occurs when the teeth are being cut. In brief, we can say that the phenomenon when the tip of the tooth undercuts the root on its mating gear. So the tip of the tooth which undercuts the root on its mating gear means then that particular concept we are calling it as the interference in the involute gears. Similarly, if the radius of the addendum circle of the wheel increases beyond O2m, previously we discussed O1n. So in case if it is increased like O2m, then the tip of the wheel on the wheel will cause interference with the tooth on the pinion. So the points M and N are called interference points. Obviously, interference may be avoided if path of contact does not extend beyond interference points. The limiting value of radius of the addendum circle of the pinion is O1n and the wheel is O2m. Just now we discussed this. So from this discussion, we conclude that interference may only be avoided if the point of contact between the two teeth is always on the involute profiles of both the teeth. In other words, we can say that interference may only be prevented if addendum circles of two mating gears cut the common tangent to the base circles between the points of tangency. When interference is just avoided, the maximum length of path of contact is Mn. When the maximum addendum circles for pinion and wheel pass through the points of tangency N and M respectively, which is shown in the figure. And here very clearly we can able to see this. This is the starting point where I was talking about K to L, the K to L point. This is the beginning of the engagement, and this is the end of the engagement. So in both the views we can able to see this, and this is the point which I was talking about, M and N. So this is the M point and this is the N point. So this is the actually the path of contact. So here you can able to see again in the pictorial view. So the gears and even the pinions. So this is the beginning of the engagement and this is the end of the engagement. This is the pinion in the clockwise directions, and this is the again the pinion in the counterclockwise directions. This is the beginning point and this is the end of the engagement point. This is the gear. So have a look on this one. If you just pause your video and if you just read this twice or thrice, easily you can understand the concept of interference. Thank you. And even we have some discussions, that is how to what are the methods which will eliminate the gear tooth interference. Particularly per gears, if interference exists, it can be overcome by some methodologies. What all they means? First thing is by removing the cross hatched tooth teeth, that is using the stub teeth. Stub teeth, we already discussed the different types of teeth. So among all those things, we'll be using the stub teeth. Then increasing the number of teeth on the mating pinion, then increasing the pressure angle, then tooth profile modification or profile shifting, and finally increasing the center distance. So with this video completes.